Hi everyone. So today we're going to be looking at graphs of rational functions, and we're looking at problems like this where part of the function is not defined. So as we can see, not the entire function is specific. So we have some variables for the constants, both in the numerator and denominator, and we also have a coefficient here, c, that's undefined. The only thing we know are the leading terms in both the numerator and the denominator. And so they're asking us where b, c, and d are unknown constants, which of the following is a possible graph of y equals f of x? Dashed lines indicate asymptotes. Okay, so how do we do this? Well, again, as I told you guys, right? Always just work with what you know. So as I was saying, always work with what you know. Sorry, my dog was barking, so I had to pause the video to settle her down. So the only thing we know is the leading coefficients, which means if I were to, again, I have no idea what B, C, and D are. I don't know what these are, but I do have these two. So if I were to say f of x is equal to 15x cubed over 3x cubed, that would be an approximation. And the only time that this would be a good approximation for the original function is if x approached positive or negative infinity. In other words, we're looking for a horizontal asymptote, right? We're looking for a horizontal asymptote. And so if x approaches positive or negative infinity, then these terms here, even though I may not know what they are, they become insignificant. They become negligible compared to these two leading terms, because they're x cubed, that's a constant. Again, as x approaches positive or negative infinity, this value of b is going to be insignificant. Likewise, this d is going to be insignificant, and so is c of x. So again, this question is asking about, what would be the horizontal asymptote as x approaches positive or negative infinity, and this is a pretty good approximation. So if we simplify this, the x cubes cancel out. 15 over 3 is 5, so it looks like the functional value is equal to 5, okay, as x approaches positive or negative infinity. So we're looking for the graph that has a horizontal asymptote at y equals 5. So let's go through that. This one looks like it definitely has a horizontal asymptote at 5. So A is definitely in the running. So we'll put a little check there. This is definitely wrong because it looks like that horizontal asymptote is at -6. So that can't be it. This looks like the horizontal asymptote's at 1. And this one looks like it's at 2. So I think we have our winner right here. Okay, and there it is. Okay, let's do one more. One or two more. So okay. So let's take like one or two more here. This one gives us the numerator polynomial, and the denominator is a polynomial. We don't know what it is. So in this case, whenever the numerator is defined, we know that we're going to have either zeros, correct? We're going to have either zeros or removable discontinuities. Okay? So again, numerator are the zeros or removable discontinuities because we don't know what g of x is, right? So let's see. Let's factor this thing. So we know there's a greatest common factor of 2, which leaves us with x squared minus 9, which then, over g of x, which will again factor into 2 times, and that's a difference of 2 squares, so x plus 3, x minus 3, over g of x. So definitely we know Well, 2 can never be 0, right? So x plus 3, we know that x could be negative 3 or positive 3, and that would make the numerator go to 0. So again, our possible zeros are x equals plus or minus 3. Now, these could be zeros or removable discontinuities, correct? Depends on what g of x is. So let's take a look at the graphs and see which ones gives us zeros at positive or negative 3 or removable discontinuities, holes at positive or negative 3. Okay, so here we definitely have a 0. It looks like we have a 0 at positive 3 here, correct? All right, here we have a vertical asymptote. Here we have a 0 at 3 and nothing at negative 3. We have a hole at 3. Again, here there's a vertical asymptote at 2. And we have a 0 at 6 and negative 6. So it looks like this can't be it. Right, sorry. This could be it right here, correct? That could be it. This has a 0 at 3 and nothing else is going on in negative 3. This has a 0 at 3 and it's got a vertical asymptote at negative 3. Okay, so we have a few things going on here, right? So my guess here would be, well, can positive or negative 3 be a vertical asymptote? Well, if we had like x plus 3 and x plus 3, yeah, it could, right? So my guess is the only one that has something going on at both positive 3 and negative 3 is A, right? We've got a 0 at 3, and we've got a vertical asymptote at negative 3. Okay, so let's take a look, and that is correct, right? Because that was the only one that had both 3 and negative 3 with some sort of discontinuity. And everything else just had only 1 at positive 3 or negative 3. Let's do one more. Here, you can automatically tell in this problem that we don't know. We don't know what these are, correct? We have no idea what these terms are here because they're all, again, unknown constants, right? The only thing we know are these in the back, which means that this thing, the only thing that this function f of x can assure us is the y-intercept. So if we now simplify this function to 24 over negative 3, that just gives us negative 8. And that's our y-intercept. That's the only thing that we know. So we have to find a graph that has a y-intercept of negative 8. So let's check. This thing definitely does right here. Does everyone see that? Right? Looks like the graph goes through negative 8 on the y-axis. So I'm going to put a little check there. This one does not. Neither does this. Looks like the y-intercept is at 4. And this one looks like the y-intercept is at negative 6. So I think we have our answer. There it is. Okay, let's do one more. This one now gives us the denominator. So again, when we have the denominator function, we don't know what the numerator is. Okay, this is looking like it's going to be either vertical asymptotes or removable discontinuities, correct? Those are our guesses. So let's factor f of x. Again, we don't know what h of x is, but we do know what the denominator is, and that's going to be x, what is it, minus 3 and x minus 2, correct? All right, so definitely looks like our candidates are x is equal to 2 and 3. So we're looking for a graph that may have vertical asymptotes or removable discontinuities at 2 or 3. Okay, again, something's got to happen. Something has to be happening at either 2 or 3, either vertical asymptotes or removable discontinuities. At 2, we have a 0 here. nothing, well actually we had 3, we have a 0, nothing going on at 2. So I'm not too sure about this. Nothing going on at 2 nor 3 here. So I'm not sure about that. Here, take a look. We have a vertical asymptote at 2, and we have a removable discontinuity at 3, at x equals 3. So this looks like a pretty good candidate right there. And here, it looks like we have a vertical asymptote at 2, and then we have a 0 at 3. Well, it's a denominator, so I'm not sure if we're going to have zeros, correct? So let's check on C, and that is correct. Okay, guys, let's do one more. Again, here, just like that one we did before, the very beginning, we don't know what these are. We have no idea what these are, correct? Pick red. We only know what the leading terms are, which means that this, we're looking for a horizontal asymptote, right? The leading terms, again, as x gets very big, as x approaches positive or negative infinity, these terms here, these terms are going to be basically negligible. The only terms that are going to be important are the leading coefficients, these two. So f of x can be approximated using negative 4x to the 5th and x to the 5th. And we can cancel x to the 5ths here. So it's just negative 4. So we're looking for a function that has a horizontal asymptote, right? Asymptote at y is equal to negative 4. All right? So which one of these has a horizontal asymptote at negative 4, at y equals negative 4? This one has a horizontal asymptote of 1, so that's out. This one has a horizontal asymptote at 3, so that can't be it. This one has a horizontal asymptote at positive 4, so again, that's not it. And final one, this last one has a horizontal asymptote at negative 4, so it looks like that one is the winner. We check, that is correct. Okay, guys? All right, take care.